Hello, welcome. In this video, we're going to be talking about graphs of absolute value functions. Now to start, I just want to remind you about the piecewise definition that we took of absolute value. And we said that the absolute value of x is equal to x when x is not negative. And that kind of makes sense because absolute value doesn't do anything to a positive number, so you put in x, you get back x. Okay, but then when x is negative, it makes it positive by multiplying it by -1. So it's negative x when x is less than 0. Which is kind of like, it feels a little off, right? Because you're like, no, it became positive. But x was originally a negative number, we make the negative of a negative number, we get a positive number, right? Okay, now we know what the graph of y equals x looks like. Okay, and I think that in Algebra 1 in Texas, we graph lines on a limited domain for the STAR exam. And so hopefully you've done this before. When x is greater than or equal to 0, y equals x. Okay, so that's just like half of the line, right? Half of the line y equals x. But I can draw that. Okay, and so that's me graphing y equals x when x is greater than or equal to 0. And I'm going to even put some highlighter on that. Okay, but then we've also graphed y equals negative x, and that looks pretty decent to me, okay? And we're only going to graph that when x is less than 0. Okay, so that's, I can grab this, and I will highlighter that in gray. And so this is the graph of y equals the absolute value of x. It is a V-shaped graph. Okay? And so now let's go and kind of like graph one the old-fashioned way by making a table of values and plotting points and connecting the dots. Okay, so let's just make ourselves a little table of values here. Let's say, that wasn't very good. I'm going to try that one more time. Yeah, make it look a little nicer. That's much better. X and the absolute value of 2x minus 4. Okay. And so we're going to say, I guess I'm just going to do 0, 1, 2, 3, and 4. I think was what I did in class, and that worked out really nice. And 4. Okay, well, then I'm taking the absolute value of 2 times 0 minus 4 is the absolute value of -4, and that's equal to 4. Okay, here I have the absolute value of 2 minus 4 is the absolute value of -2, and that's going to be positive 2. When I plug in x equals 2, I get the absolute value of 4 minus 4, so I'm taking the absolute value of 0, and that's going to be 0. When I plug in x equals 3, I'm taking the absolute value of 6 minus 4, and the absolute value of 8 minus 4 is going to be, well, just the absolute value of 4 is going to be 4. Okay, so now I can plot all these points and connect the dots. I'm seeing yet another V-shaped graph. Okay, these were supposed to be portions of lines, but they were a little curved looking. Okay, and there's a couple of things I want you to notice off of this. Okay, I think I'm just going to say it wouldn't be too much to expect that it might continue going on that way in the same way. Okay, now I'm going to clear all this out, and I'm going to show you the two things I want you to see. Okay, I want you to notice, first of all, the x-coordinate of the vertex. I meant to leave that table. That's what I did in class. But okay, the thing about the x-coordinate of the vertex is it's the x value that when I plug it in, it makes me take the absolute value of 0. Okay, if you go back to that other graph, notice that vertex point, that sharp corner, happens where I'm taking the absolute value of 0. Okay, and it's also where the behavior suddenly changes. If we went back all the way up to the definition, and we saw that like it's right here at x equals 0 where the behavior is suddenly changing, well, it's where we took the absolute value of 0, and that's going to cause us to have a sharp corner, or that vertex is what we're calling it. Okay. So as far as, finding the x-coordinate of the vertex, we can say, okay, well, that's just where 2x minus 4 equals 0. Okay. Yep, still on my shot. Add 4 to both sides equals 4 divided by 2, x equals 2. Okay, that's how we're going to solve this in the future. But then there's another thing I wanted to show you, and that's kind of about like the slopes, right? Okay, so the slopes of this are slope of positive 2 and slope of negative 2 over here. Okay, and if I go over here and I, say, okay, where did that come from? What caused me to have a slope of 2 and negative 2? It's from this 2 right here. Okay, not from the fact that we went, the x-coordinate of the vertex is 2. Okay, but I think that's all I've got to say about this particular example. Those were the two things you're supposed to notice. All right, and to just like really explicitly write this out for you, if I want to find the x-coordinate of the vertex of the sharp corner on the graph of an absolute value function, I'm going to grab whatever's on the inside of the absolute value, and I'm going to set it equal to 0. Okay, so setting inside of the absolute value to 0 and solving for x. Okay. And then we can find the y-coordinate of the vertex by taking that x-coordinate of the vertex and plugging it in for x and just computing y. Okay, so plugging in the x-coordinate of the vertex. Okay, so I'll do this once for you, and then I'll just give you an opportunity to try it on your own. So if f of x is equal to 2/3 of x plus 4 plus 5, and I want to find the coordinates of the vertex, what I'm going to do is I'm going to start with the inside of the absolute value. I'm going to pull that over here, and I'm going to say, all right, to find the x-coordinate, I'm going to set x plus 4 equals 0. Okay, and then I'm going to subtract 4 from both sides to discover that x is going to need to equal negative 4. Okay. And then to get the y-coordinate, I'm going to say, all right, well, f of 4 is where I replace x with 4 everywhere I see that. No, negative 4. Whoops. Yeah, I was going to say, I need to be taking the absolute value of 0. Okay, so f of negative 4 is going to be 2/3 of the absolute value of negative 4 plus 4. Okay, because taking the absolute value of 0 is where it changes, where we're getting that sharp corner, that vertex on our graph. And then I'm going to add plus 5, and I'm going to say, oh, okay, that's equal to 5. And so I know that, well, f of x, that means y. Okay, so y equals 5. So the coordinates of my vertex are negative 4 and positive 5. Here's one for you to try on your own. So f of x equals 2/3 of x minus 4 on the inside of the absolute value minus 5. You should try to figure out the coordinates of the vertex on your own. You should pause the video in a second and work it, and then resume playing the video so you can check your answers against mine, because they're going to pop up in like 5 seconds. All right, there you go. So I took the inside of whatever was on the inside of the absolute value, and I set it equal to 0, and I solved for x. Okay, I got x equals 6. And then I'm going to find the y-coordinate of the vertex by plugging that x value back into the equation, right? Back into f of x. So I find f of 6 equals the absolute value of 2/3 of 6 minus 4, and then subtract 5. Okay, well, check to make sure you did it right. You should be taking the absolute value of 0. 0 minus 5 is not 5. What am I doing here? Okay, it's equal to negative 5. Actually, maybe I'll just keep that as my negative. Okay, and so my coordinates here are positive 6 and negative 5. Okay, well, that was pretty messed up, but it'll. All right, here we've got another example. Okay, talking about the 4 quadrants of the xy plane. So I'm just going to remind you that, okay, where x and y are both positive, that's quadrant 1. Quadrant 2 is over here where x is negative. Quadrant 3 is where both x and y are negative, and quadrant 4 is where x is positive but y is negative. Okay. So if a is a positive number and b is a negative number, which quadrant contains the vertex of the graph of y equals absolute value of x plus a plus b? All right, so what we're going to do is, just like always, we're going to take the inside of the absolute equal to 0. So if I have x plus a equals 0, I have x equals negative a. A is a positive number, so that means the x coordinate is negative. Okay, So I know I'm either in in quadrant 2 or in quadrant 3 with my vertex, right? Okay. So that what I might say is that the x-coordinate of the vertex is less than 0. Okay. And then, well, the y-coordinate of the vertex is going to be equal to the absolute value of x, which we know is negative a, plus a. Okay, that's going to be the absolute value of 0, which I would expect because I know that's what's causing the vertex, plus b. And, okay, that's just y equals b. And maybe you've noticed at this point that that number that's kind of hanging out added onto the outside of the absolute value, that's going to be the y-coordinate of the vertex, okay? And if you have, good for you, okay? If you haven't, just keep doing what I'm doing where you plug in the x-coordinate under the vertex and eventually you will see the pattern. Okay, y equals b, and they said a is positive and b is negative. Okay, so the y-coordinate of the vertex is going to be a negative number. So if the x-coordinate is negative and the y-coordinate is negative, then we are going to be our vertex is going to be over here, somewhere in quadrant 3. So my answer would be quadrant 3. All right, now I think it's time for me to show you about how to sketch your own graphs of absolute value equations in a way that's going to be a little bit faster than, making a table, plotting points, and connecting the dots, right? And that's going to be why I spent the past, 10 minutes or so telling you about how to find the vertex. That's going to be our starting point. So we're always going to start with the vertex. Okay, so this fact over here where it says absolute value graphs are symmetric across their vertex. Well, we saw the first one, y equals absolute value of x. It had slope 1 and negative 1, and it was symmetric across the y-axis. And then we did one where, I forgot what the actual equation was, but I remember what it looked like. It looked about like that. And it had symmetry across its vertex as well. Okay, and that's just going to be true in general, and you can believe me, or you can go to Desmos.com and graph a bunch of absolute value equations and see that they're all going to be symmetric across their vertex. Okay. So our first step is going to always be plot the vertex. So I think what I'm going to do is I'm just going to solve for the, x and y coordinate of the vertex. So I hope I left myself enough room to work this. Okay, the vertex is going to happen over here where I grab x plus 1 and I set it equal to 0. And that's going to be x equals negative 1. Okay. Yeah, and then y is going to be equal to 2 times the absolute value of 0 when I plug in x equals negative 1. Plus 3, and we know the absolute value of 0 is 0. So that's going to be y equals 3. Okay, then we're going to plot one other point. Okay, so I'm going to say, all right, that was a little rough. That's just going to have to do. Okay, so if x is negative 1 and y is 3, I'm going to draw this one a little bit out of scale. Okay. What we're going to want to do is plot one other point. I mean, really any point besides x equals negative 1. Okay, I'm thinking, for my own, I'm going to choose x equals 0, right? And I'm going to say, all right, when x equals 0, y is equaling 2 times the absolute value of 1 plus 3, which is going to be 5. Okay, so I go over here to 5. I plot that point. Okay, now I'm going to use the symmetry. So it's kind of symmetric across the vertex. And if I went to the right by 1 and I had a y level of 5, I could go to the left by 1 from the vertex and have a y level of 5. And then we're going to, that was a little bad. Okay, here and there, and we've got ourselves a sketch of the graph. And we didn't need a grid, we didn't need to do any painstaking calculations of a bunch of points. We just plotted the vertex, plotted one other point, used the symmetry, and then connected the dots, and we were happy and we're ready to move on. All right, now let's just do some more graphing examples. And I was thinking I brought in the grid here, but I don't think that's going to be necessary for either of these two examples, so I'm going to take it away. Because honestly, I just prefer to graph on a blank slate. Okay, the grid, it's almost like too much pressure, it makes you want to be like too perfect. And that's not what we're about here. Okay, we're about getting a good, quick, accurate sketch. Okay, so if I want the vertex, I'm going to start with that. Okay, that's going to be 3x plus 6 equals 0, and 3x equals negative 6, and x equals negative 2. Okay, then I'll see that y is going to be the absolute value of negative 6 plus 6. Okay, so it's going to be the absolute value of 0 minus 1. Okay, and so that's going to be y equals negative 1. Okay, I've got myself a coordinate, negative 2, negative 1. Okay, so that's going to be negative 2. That's going to be negative 1 over here. And I'll just kind of plot my vertex. Okay, I'm going to plot one other point. I'm definitely going to choose x equals 0 since, you know, it's kind of like right there for me. My other point is going to be x equals 0. So y equals absolute value of 3 times 0 is going to be 0, plus 6, it would just be 6, minus 1, and that's going to be 5. And, you know, this is my graph on a blank canvas, so, you know, if I make this negative 1, it doesn't have to be to scale. I can say that's going to be 5. And that's going to be my second point. So if I went over that far, I need to go over that far again, and it just looks like it's about going to be like that. That's going to be good enough for our purposes, and I just go through here, sketch these, and I've got myself a really good sketch. Okay, now I'm going to let you try this number 2 on your own. Okay, now this one's got a little something that's going to go different, but if you observe the same 3-step process I've been showing you, you should be good. If you can identify the coordinates of the vertex, plot one other point, and then use symmetry, you can't go wrong. So I'm going to let you try this on your own. You should pause the video, right? Because I'm going to work it while it's paused, and then I'm just going to flash up the answer here in about 5 seconds. All right, there you go. So I found my vertex. That was it, where x is negative 2 and y is positive 4. I plotted another point. I again chose x equals 0 because I like to make computations with zeros, right? And then I used the symmetry. Okay, the one thing that you're going to need to notice about this is that because the number, the coefficient in front of the absolute value was negative, that caused the v to go upside down. Okay, and so the v opened downwards. And, you know, we'll have more to say about that later on in the course. But for now, I think that's pretty much all you would need to know, is that a negative number of absolute values causes it to open down like that, whereas a positive number of absolute values gives you a regular looking v. Okay, I think I've got a couple more examples here. All right, yeah, this is the one that needs the graph paper. So let f of x equal 4 minus the absolute value of 4/3 x. Let R be the region enclosed by the graph of f and the x-axis. So we're going to start by sketching the graph of y equals f of x. Okay, so in order to do that, I'm going to need to find a vertex. And that'll be where x is, okay, 4/3 of x, the inside is equal to 0. And x equals 0. And the y coordinate will be f of 0, which is 4 minus 4/3 of 0. Okay, that's just going to be 4. You can't really see that, but I think you know what it says, right? It said that the y coordinate is going to be 4. Yeah, I'll move it there. Okay, we've got the vertex. It's at 0, 4. We're going to get another point here in a second, but I think that I'm going to just kind of prepare for this. Oh, okay. But that's the thing about it makes you feel like you got to be perfect, and that if your y-axis is all messed up, that you got to keep redoing it. Okay, and that's what I'm trying to avoid by convincing y'all to maybe not graph on a grid as much, and maybe graph on a blank, sketch on a blank slate more often. Okay. So I'm here, I've done it, I'm going to plot the point 0 and 4, okay, and then we just need one other point. Now, we're going to need to be strategic about that point, okay, because we've already chosen x equals 0, but I've got that 4/3 x. So if I'm thinking about what kind of number I want to put in there, I want to put a number that's divisible by 3 so that y is still a whole number and I can graph on my grid, right? That's why I brought in what looks like graph papers so that I can plot points accurately. Okay, so I'm going to choose something divisible by 3, like x equals 3. Okay, so then y is going to be equal to f of 3, which is what I get when I plug in 3 for x. So 4 minus the absolute value of 4/3 times 3. Well, that's times 3 over 1. 4 minus the absolute value of 4. Oh, that's 0. Okay, well, I can do that. 3, 0. Okay, I'm going to use symmetry. If I went to the right from, x equals 0 and I was on the x-axis, I should be able to go left 3 from the y-axis and still be at y equals 0. And then I'm going to connect these like that. Okay, that's the graph of f in red. Okay, region R is what I'm about to highlighter here. I'm about to shade it in highlighter, and it's going to spill out a little bit, but you know what I'm going for here. It's not a precision highlighter. Okay. This is what we would call region R. All right, and a region enclosed by a function and the x-axis is really something we're going to be super interested in calculus. So that's kind of part of the reason why we bring these concepts in Algebra 2, okay, because this is at its core a pre-calculus class. Okay, now part B, we're going to find the area of R. I'll work that in blue. Okay, we know that area of a triangle is 1/2 times the base times the height. Okay, so I should be able to find the width of the base. That's looking like 6 to me. Yeah. You could count the squares, or you could say it's the coordinate of the point on the right minus the coordinate of the point on the left. So it would be 3 minus -3. Either way, that base is 6. And the height is going to be 4 because, it's there. Yeah, you can see it. So that's equal to 1/2 times the base, which is 6, times the height, which is 4. Okay, and then I felt like, oh yeah, I was going to talk about perimeter. I know, if we're going to talk about perimeter, I probably need to clear out the discussion in blue. Okay, and maybe I'll switch over to green. Okay, for perimeter, we already know that the bottom is 6, but that's actually not going to be enough for us to figure it out, because it's like we've got 3, and we've got the height in here is 4. Okay, but that's not going to help me with the perimeter, right? I'm going to need to go over here and say, all right, perimeter is going to be, I'm just going to add the side lengths together, but I got to think, what's going to happen here? How do I figure out that? It's a 3, 4, 5 triangle. Okay, and if you are the type of student, which most of y'all are, about to take the PSAT sometime soon in the next month or so, well, you need to remember your 3, 4, 5 triangles, and you should probably also remember your 5, 12, 13s. I made sure to put that one on the homework too, because those are on every SAT, ACT, and PSAT, right? Your Pythagorean triples. Don't forget those. Okay. Sometimes people forget about 5, 12, 13. Don't do that. Okay, you don't want to forget. Fewer people forget about 3, 4, 5, but in case you were about to forget, I'm just reminding you. Okay, so the perimeter is going to be 5 plus 5, and then the length bottom is going to be 6, and that's going to be 16. I'm realizing I never simplified the area, but that's going to be 12. Okay, and that's going to be all the examples I've got for you for this video. If you feel like you need more practice, well, you should work the homework set, and if that's not enough, then you could go see the extra practice and just get to work, and this will get easier and easier with time. Thanks for watching. Hope this helped.